Hey YouTube, Jojo here with Tipsy Python, the casual guide to learning Python, and today we are really getting into it. We're going to talk a little bit about data types. We're going to talk about variables in Python, and you know what, we're just going to cut straight to the chase, and we're going to make a little command line interface program so you can get started writing programs on day one of learning Python. And all the while, we're going to be doing it with my friend, Colonel Blanton. Blanton's is one of those interesting bourbons that connoisseurs like to enjoy, so this is one I'm pulling all the stops out today just for you guys. Maybe I should just skip the lesson and drink today. Alright, enough messing around. I'll save that for the end. Let's get into it. If you're following along, go ahead and open up PowerShell or your IDE or Notepad or whatever you're using to follow along. I'm doing print, open the parentheses, hello world, close the quote, close parentheses, and I'm hitting enter, and I'm returning hello world just like we're telling it to. We're telling it to print hello world back to the console, back to us. Now, actually, for posterity, I think I'm going to do this in a Jupyter Notebook. I've already installed Jupyter Notebook, but if you're following along, you can do this in Google Colabs, or you can download it yourself to get started. And the reason I'm doing this in Jupyter is I want to save my outputs, and I'll post this later. I'll put it on my GitHub and I'll link to it down below, and you guys can check out exactly what I'm coding today. I'm going to add some cells here. So a second ago, we did this command. We said hello world, and we executed it, and we got hello world back. Now this is a very simple command, but there's a lot of nuances that you have to pay attention to detail and do it just so. For instance, Python is case sensitive. If we type capital P print, we're going to get a name error. There's no such thing as capital P print. Only lowercase p print is defined as a function. Don't make that mistake. Python is case sensitive. Another one here is that we have to be sure that we use the quotes. If I just try typing in hello world without quotes, I get another error, invalid syntax. So again, when we're using strings to write messages or text, make sure you use the quotes in the appropriate quotes for the case. Let's do some more print exercises. So we'll print today is the 13th. Execute, today is the 13th. We could even print 13. Works just like we thought it would. But what happens if I try to print 13 without the quotes? What? What's going on here? So we saw just a second ago that if we try hello world without quotes, it blows up. But if we do 13, it seems to work just fine. Now, why is that? And the answer here is data types. There's a concept that different objects in Python have different types. For instance, if we do something in those quotes that we've been using, Python knows that it's a string object. And if we do something as just a number, Python will know that it's an integer. To double check this, we can actually use the type function. We can do type 13. We see that Python understands this as an integer, but when we do it inside of quotes, it becomes a string. In the last video, I briefly mentioned that Python is dynamically typed. Now, this is an important part of the language because Python goes off a set of assumptions with how we make the code. We don't have to specify that we're using a string, but just by the way that we format the code, we tell Python to infer what we want. And for me personally, even though there's a little bit of wiggle room for error in here, this is one of the things that's really attractive about Python, because in other languages, let's say Java, that's statically typed, you have to specify every time that you're saying something, every time you're setting an object, you have to say this is a string or this is an integer. Whereas Python, we just get to go off the assumption, and Python and us, we're just kind of on the same level, and that makes it really nice when we're coding. If you have some programming experience, this is going to seem very familiar to you because the idea of data types is common across many languages, but let's just look at a few more of the common ones that we have available in Python. We've seen string, we've seen integer, we could do something, let's say like a floating point decimal. Python has a data type called boolean, which represents true and false. And pay attention to the nuance with this one. It's not a string, T-R-U-E. It's not the string and text object at all. It's its own binary object, one being true, one being false, the boolean object. And then we can get into some of the collection data types, like list is a common one used in Python. We could have tuple, and dictionary is another big one that you see really often. This isn't an all-inclusive study so far, but I'm just bringing up some of the common data types that you're going to see when you're programming with Python. Let's look at a few of the more esoteric ones, or at least understand how they'd be used. So going back to the command line, I'm going to say import datetime and execute. And there was no output, but just understand that the import keyword says grab a piece of code and include it here. And then we can use this datetime. Like we can say datetime.datetime.now, and I get today's date output. Another one of the big ideas here is that Python is object-oriented. Everything in Python is an object and has a type. Even these things that we're importing, if I say type datetime, it's a module. And if I take the type of this function that we were using, I can see that it's the datetime object type. Guys, I know I'm getting a little rambly here, but this idea is very important, that there's some standard library objects like string, like integer or float, and then there's other code objects that can be pulled in from external modules like datetime. Since we've talked through data typing a little bit, let's get to another concept of not just Python, but programming in general. Let's talk about variables. Now, I can write code all day, and I can write code of all different types. I can have threes and hellos and date times and all this good stuff. But it doesn't make any sense if I'm just writing a piece of text. Like, what's the point of programming if it just does the same thing, if it outputs the same thing over and over again? And that's where variables come in. See, variables are just like they were in algebra. They're pieces of code that represent something else. Perhaps they can be placeholders for another object in the code that we're not directly referencing, but it's a link to it. Let's just try this out for ourselves so that we can see what we're talking about. If I say hello, it outputs hello. The object just returns itself. But what I can do is I can set hello to a variable. So I can say h is my variable equal to the string hello. Nothing was output, but an action took place here. H retained the value that we assigned to it. We assigned the string hello, and now h is holding on to that for us. So if I reuse it later in my code, print h, I get the value that was assigned. And this isn't just applicable to strings. There's a lot of things that we can do with this. We can assign integers and use them later. And of course, as we're adding these layers of abstraction to the code, it's good to have an easy way to check into what the values are. So like we saw, we can just print something out, or we can even use that type function that we were using earlier to check what data type a variable is holding. And throughout our script, as we're using these variables, we can actually overwrite them. We can reuse them as different things. Now that we understand some about data types and now that we understand about variables, let's talk about how we use these things together. So let's first examine strings a little bit and talk about string manipulation. One of the big concepts here is called concatenation. And guys, don't be intimidated by the name. Concatenation is just one of those like fancy words that programmers like to use. It just means putting two strings together. As an example, we could do something like hello. I'm going to use plus Josha. And we see we concatenated these two items to return as a single string. And Python actually has a lot of ways of doing the same thing. For instance, if we're using a print function, we can say hello and a comma. We put our second string and actually concatenates them, in the comma inserts a space for us. Another way of doing this would be to use the format method. So we could say hello, and we can put this empty brace placeholder where we want to insert some more text. I'm going to say format, and I'm going to put in what I want to go inside the braces. Format is a really nice method. It does a lot for us. It's really nice, but just this syntax of using dot format and putting some stuff after the text, it makes it tricky. So thankfully, if you're using Python 3.6 or later, which if you downloaded the newest version, you're on Python 3.8 as of now, we can use formatted string literals, or F strings as people call them. These are real simple to use. Let's start with a variable. Let's say x equals tipsy Python. And if we want to format that into a string, say print hello. I'm going to put an F at the beginning of my string to say I'm formatting this string. I'm going to put braces like I did when I'm using the format method, but really I'm just going to go in here and insert the variable that I'm using. Like I said, this is nice because it even converts data types for us. If I wanted to go in here and say, hello, Tipsy Python, you have this many dollars, it combined the string and the integer really well, and it didn't require any overhead from us. Now, of course, when working with strings, sometimes you're going to hit some silly errors. So let's say I say, hello, y'all. I get a syntax error because inside my string I was using a single quote, and that's actually what I was using as the delimiter, saying this is what my string text is. One solution we could do here is that we can use single and double quotes interchangeably. Another way to approach this problem would be stick with single quotes, but I'm going to use the backslash character to escape the single quote. That means to take away the special meaning that a character has. And when I execute, it works just fine. Perhaps even another way, I'm going to use what are called doc strings in Python when I use 3 quotes in a row. Hello, y'all. That works fine as well. And while I'm talking about it, one of the nice things about doc strings is that even if I do a line break in here, it's going to retain that in the output. A doc string in Python can be a multi-line string. This isn't the only way to do it though. I could actually go in here, remove the doc string triple quotes to singles. I could write the new line character myself, and then I could escape this single quote, and we have one nice long string with a new line character embedded in there. And I know what you're thinking, what if I actually want to use the backslash character inside my string? No big deal. You can use backslash to escape itself. Just going to go here, take this away, and now I have a backslash inside of my code. This is not a big deal. Python makes programming very easy. Let's take a second and talk a little bit about some arithmetic. Now, just like integers work in regular math that you'd write out, I mean, the math works pretty much like you'd expect it to. So going into writing my code, add some new cells here. If I do 1 plus 1, I get 2, just like I thought I would. Or if I get 1 minus 1, I get 0. If I get 0 minus 1, not 0 minus exclamation point, 0 minus 1, I can do negative integers, no problem. I can use the star for the multiplication operator, and I can also do division. You'll notice here that returned a float and has the exact value. If I want to, I could use a double slash for the floor operator. Actually goes into this 0 times, but I can use that in conjunction with the percent, the modulo operator, to get the remainder from this fraction. We can also use the multiplication to do things like exponents. We could do 2 to the power of 3 or 2 to the power of 10 or whatever we want to do in there. We can perform calculations really easily with Python. Now, just going off of what we have so far, we already have variables under our belt. We got string manipulation. We got some math. We pretty much have what we need to make a program. I'm going to throw in a couple other functions, but really we've been using functions already. I do not believe that you need to have a math background to program well, but a couple of these simple core concepts are built out of algebra. For instance, f of x, like you'd write a function in algebra. This is pretty much the same way that things work in Python. As a matter of fact, we've already been doing this. We've been using a function named print this whole time. They work just the way that you think they would. You have the function name at the beginning. Inside the parentheses, it takes some arguments, and then it performs an action and returns it. And functions are a foundational code concept. I mean, we use them all over the place in Python. Later on in this series, we're going to talk about defining our own custom functions. But for now, suffice to say that I've been using standard built-in functions from the Python library. Now, let's look up a list of these. I'm just going to Google real quick, Python standard library functions. And when I look at the documentation, I'll see that there's a big list in here. I believe there's 69 as of Python 3.8. And some of these faces look familiar. Like I said, we've already been using these. This guy print, we've used him. We've used type. And to build out a simple command line application, I'm going to take just a few more of these built-in functions. I'm going to use float that takes an input and then returns a floating point number, the float type that we talked about earlier. I'm going to use input. It takes user input from the command line. And I think I'll probably use round as well, which just rounds a number. Are you having fun yet? Let's get it. My idea for this application is in Texas, we have a state sales tax. It's like 8% of whatever you buy. So if I go to the store and I buy something, I think I know the cost of it, and then the government throws a little bit more on top and I get surprised. But using Python, I can build a simple calculator that I can input a price and it'll tell me what the actual sales price of it will be. So let's build that out real quick. I'm not going to use Jupyter anymore. I think it's best to actually write a script as a standalone Py file. We can do that really simply. I'm just going to go to my desktop. I'm going to say new. I'm going to use a text document, but I'm not going to keep the .txt extension on the end. I call this calculator.py. That's fine. I like to use Sublime Text when I'm editing. Now, the first thing, it's kind of convention. I'm going to say user bin env python 3. So here's how I'm envisioning this app. We're going to have a command line that prompts the user. It asks you like, hey, what's the price of the item? I'm going to input a price. It will calculate the final price with tax, and then it will print it out to me. Now, from the documentation, I'm going to use the input function that we looked at. We put a prompt in here, so we're going to say, what is the item price? And this is actually going to print out a prompt at the command line that asks me this question. I'm going to input something, and it's going to be returned by the input function. We're going to catch the input by saying input price. So we're going to have a variable that catches the user input. An important note about the input function is that it always returns a string object. It assumes that the user is typing in some words and it returns a string. Now in this case, I'm calculating prices, so I don't want a string, but I want to format it as a float. So I'm going to do another line. I'm going to take this input price variable and I'm going to set it equal to a float of whatever the string is. Now in Texas, the tax rate is 8.25%. I'll say total cost equals 1 plus my tax rate. So at this point, my total is going to be this percentage times what the user input. And I'm going to print out the total after tax is total. Now one more thing about this, if I run it, it's just going to run one time. The user's going to input something, it's going to calculate an output, and then the program terminates. That's not the behavior that I'm going for. Really, I want this to happen in a loop, that as prices are calculated, the user can continually input those. So we're going to talk about this more later, but for now I'm going to say while true, and then all these lines I'm going to indent with 4 spaces. Make sure you're not using tabs, use spaces. I mean, tabs actually do work, but what can I say? I'm biased. Okay, save. And when I go back, I'm going to double click on calculator.py. It's going to prompt me for an item price. Let's say that my item cost $90 and the price after tax is 97.425. I forgot the last part of this is I want a round. I want this to be actually in dollars. So even in here, I'm just going to say round the total. I'm going to use a comma, say round to 2 places. All right. I'm going to restart my program. The price is 90. It gives me a very nice total of 97.42. Now, I know that this isn't a fancy application. Like, you're probably not going to impress someone with this. But if this is your first time programming, you should feel proud to make something like this. I mean, I feel proud to make something like this. Like, anytime that I can create new functionality, that the computer is doing something instead of me doing it, I feel accomplished and I feel proud of myself. That's all we got for today's lesson, guys, but really we went through a lot. We covered a lot of ground. We talked about variables, we talked about data typing, we used several built-in functions from the Python library, and we made a command line application. Not to mention enjoying a little pour of this Blanton's Bourbon. Man, this stuff is really good. It's one of my favorites. I mean, if nothing else, this is just a really cool bottle. A cool note on these is that they have little letters with the horse and different positions of running, so as you get different bottles of it, you'll find different horses. Really solid nose on this bourbon. I mean, I get something like a s'mores from it. Like, there's the oak, there's a sweet, even more so on the palate. I mean, I have that s'mores flavor, but I have a nice bouquet of like these light floral notes of like maybe some light fruit, a little bit of baking spices in there. I mean, it's just a super solid staple pour. You can't go wrong with a bottle of Blanton's. Alright friends, you made me proud today. I hope you learned something. I hope you enjoyed the video. Until next time, Tipsy Python.